7.8 Three-dimensional trigonometry. Recognizing right-angled triangles inside of 3D objects can be a very difficult task. So what we want to do is we want to attempt to isolate each piece of information that we've been given. How can it be used? How can I create a right-angled triangle from that? Next, what we want to do is we want to plan steps to solve the problem. Where do I start? How many triangles do I need to create? I asked Mr. Speiser about this visualization using the language, the coding language, Python. And what's so great about this demonstration is it really highlights where that right angle triangle is within the rectangular prism. So I'm going to have the link to this in the description of this video, but you can see here that this literally lives inside. So if I take a bird's eye view here, I'm just gonna I'm gonna bring this over. So if I can highlight, when I look at the bottom here, I see one right angle triangle and I see another right angle triangle. And this right here, this diagonal here, if you project it up, that's another right angle triangle. So whenever we're trying to find a body diagonal, now a body diagonal is that orange kind of line that goes from the top of the rectangular prism to the bottom of the other side of that rectangular prism. That's called a body diagonal. And any time that a body diagonal is used in a question, you will need to find we'll need to use two right angle triangles. So obviously this one right here, the one that's right inside the body of the rectangular prism, but then this one right here, okay? And it looks kind of tricky because it looks like that, where the bottom of the right angle triangle is, it looks like that's where the right angle is, but when you look this way, you can actually see that the right angle is in the bottom left corner. Okay, so let's look at, so again, the website to this is going to be in the description of the video. So let's move on to the example that I've prepped. So here's an example of a cuboid, or a rectangular prism, with a body diagonal that goes from C to H. And we want to figure out what Y is. Okay, so that's this one right here. Another way that we can write this Y, or name this Y, is going to be FH. That's the line that goes between the vertex of F and the vertex of H. And we have X, which we can also call CH, because X runs from the point C to the point H. And then what we're going to do is we're going to find out what the angle of FHC is. So FHC. That's the diagonal that runs vertically. Or sorry, that's the angle that's created as a three-dimensional shape in the rectangle. So if I can get this, that's the angle that goes from the bottom right of this to the top left. It's the angle that is with the bottom of this rectangular prism and with the body diagonal. So it's the bottom angle in the right angle triangle. So I hope that you can see how that visualization can help you out. So please don't be hesitant to go there. Okay, so first things first, let's find this angle here. I'm just going to use a different color just because I find that helpful in organizing my information. So I have this triangle right here. It's my blue triangle. So I'm just going to redraw it so that it's flat. There's no perspective on it. So this one right here we know for sure is 4 meters. And the only thing is we aren't directly given this one. But if we find a line that is parallel to this one, so this one right here is also parallel. This one is also parallel. And a length is given to that. So we know that this one right here is also 5 meters. So that means that this one here is 5 meters. Since we've been given two lengths, the easiest way to find y is to use the Pythagorean theorem. So y squared equals 4 squared plus 5 squared. Y squared equals 16 plus 25. Y squared equals 41. So that means the square root of y squared, which is y, equals the square root of 41. I can take out my calculator here and it can say 41, find the square root of that, and it's 6.4 meters. Okay, so we've figured out y. That's awesome. So now what I'm going to do is I'm going to use a different color and highlight the other helpful right angle triangle. So this one right here is going to help me find my x. So I'm just going to redraw that. Now I know that the base that it's sitting on is y, but we just calculated y. Y is 6.4. So I'm going to put 6.4 right here. The height of this is going to be the same as this AH. So CF is parallel to AH, so that means that this is going to be 6 meters. So that means that this height right here is also going to be 6 meters. It might be helpful if I write down the actual letters here. So if I go C, F, H, and I'm just going to go back and say that this is my G, this is my H, and this is my F. Okay, if that helps you visualize, I hope that's helpful. So again, we have two legs here, so we just need to use our Pythagorean theorem to figure it out. So x squared is 6 squared plus 6.4 squared. X equals, I'm just going to do it all in one step here. So 6 squared, which is going to be my 36, plus 6.4 squared equals, x squared equals 76.96. And if I take the square root of both sides, x equals I'm just going to say 8.8 meters. Great. So now here's an extra little step here. We're looking for, okay, so I'm just going to check mark this in green. I'm going to use red this time. We're looking for this angle right here. So that means if I were to draw this into the right angle triangle that I just did, we're trying to find that angle there. So using the information that we've been given, now we can't help but use one calculated amount, which is 6.4, but that's okay. I'm going to use tan because I have my opposite and I have my adjacent. And if I call this theta, so if I say tan theta equals opposite, which is 6, over 6.4, which is my adjacent, I'm going to say that angle theta, or I can also say angle FHC, that's just a shorthand for angle, okay? So I'm going to say tan inverse of 6 over 6.4. So I go 6 divided by 6.4 and I hit my equal sign. I'm going to tan inverse that. So that angle is 43.15 or 43.2. So therefore theta equals 43.2 degrees. And we have solved for that angle. So if you're finding this difficult to visualize, and if you are, let me just say you are not alone. This is hard stuff for me to visualize. Please don't hesitate to use that really helpful visualization using Python that Mr. Speiser did. Again, it's in the description.